Hi everyone, welcome to Data Topogon Cool Runnings 2024 conference. And thank you firstly for choosing to be in this room. That really means a lot to be here. So yeah, I know the reason that you are here is because one of the reasons could be that you would be interested in real-time motion tracking or object detection, Azure AI, and Microsoft Fabric services. So yeah, let's start with that. A little about myself. Who am I? I'm a data engineer consultant at Amestra Analytics. I have a master's in business analytics at BI Norwegian Business School. I have a high interest currently in Azure AI, Databricks, Power BI, and Microsoft Fabric. As you can see, on the free time, I'm mostly in the nature or hiking or fitness training or board games. And you can find my LinkedIn here. I would love to connect to you all and love to hear your feedback after the session. Yeah. Yeah. So near real-time object recognition using Azure AI and Microsoft Fabric. So what is the architecture that we are using here? So we have an object. Right now in this session, we will have a real-time demo and also a workshop of how we can do this real-time object recognition, not just detection. There is a difference between detection and recognition, right? So here I have different objects in front of me. I have a different camera on my right, and I have this camera. And right now I'm using a IoT device, or I could call it a laptop, where the data of the camera feed will be sent into the cloud. And using this streaming, we will send the data to Event Hub namespace, in which we have an Event Hub. But what we will be sending to that? We will send the camera frame, the image, to the model endpoint, which is in the Azure ML workspace, which is part of the Azure AI services. So we have a Azure ML workspace, and in that Azure ML workspace, we have a model called YOLOF, and we have a model endpoint to that to detect the images or the frames in the images and recognize the objects based on what the object is. So that string will be sent into the Azure namespace and Azure Event Hub. And once the events are ingested into the Azure Event Hub, then they are captured into a stream job in a Fabric workspace, where the stream job, we will do some real-time transformations, and that will be sent into a Fabric item called Reflex. If you have heard about Fabric, we will be highly focusing on real-time intelligence, which is one of the latest features which was introduced in Microsoft Build event this year. So we will be using the Reflex Fabric item to analyze and see this data in real time in less than a second. And we will also get real-time alerts if there is a specific object or a specific item. And we also want to store this data, which we will use Event House and a KQL database with some retention on that. For example, if we have a data which we want for the last 3 hours or last one day, which is most probably in a scenario like airport or a scenario like a factory, which we can use this real-time object recognition to recognize different objects. So here I'm considering a scenario of an airport. For example, there are like different cameras in the airport, and the camera uses the object recognition to detect these objects and sent into the Fabric workspace where they are stored into the KQL database. And then we will also be using a defined query set, which is a KQL query set. And then we will also see those insights in a real-time dashboard. Yeah, I hope it's clear, the architecture diagram, and we will also see this architecture at a stage, at each stage once we are completing different levels in the presentation. So the first part, a bit theory of or a background of what is Azure AI services and what are the part of it and what are we going to use in this presentation. So Azure AI Services is a part of Azure Cloud environment where the Azure AI Services provide different types of services like video indexer, which we can send the video input, and they can tag, and it can tag multiple objects in that videos. And also we have Azure OpenAI service, which is kind of uh, which is kind of highly in demand for many enterprises to specifically use OpenAI services. The reason why Azure OpenAI services need to be used is because when you use OpenAI in a OpenAI or a ChatGPT Pro, the data or the models are being trained on the chat history, right? But when you're using it on Azure environment, the data or the texts that we sent into the model are not trained, and they are saved in the organization environment. So as a part of this presentation, we will be using the Azure Machine Learning Studio, and we will use a particular model from the Azure AI services as well. So the model that we are going to use is you only look one level feature, and we will come down to that why we are using this feature and what are the different types of models present in this. So once I open my, so you can create a Azure AI resource here. For example, so here you can create Azure AI Studio resource in your Azure environment or a tenant. I have already created the resource. So here we have a hub called Azure AI Hub, which is part of my resource group and particular subscription on this. So when we open the hub, we don't see any models that has been deployed or anything right now, right? But we want to use object detection models. So here we have different types of inference tasks that we can use. And one part of that is object recognition. So here we will use object detection. And these are the models that are available in Azure AI Studio, which is also the AutoML image object detection is also one of the part of the models here, where it can particularly tag particular image. For example, if we can train these models on particular object, if it is a cup or a carton or a bottle, so it can be trained on the data and can be used in a factory environment. And out of these models, why we are using this particular model, YOLOF, which is you look only one level feature, is because it's fast and it supports real-time inferences as well and real-time object detection. So let's see more about the model here. So the model, why do we need to use YOLOF? Because it's a single layer model. It makes it easier for object detection. And it performs in a high speed environment as well and gives a high accuracy. And it's very efficient compared to the other models that are in the Azure AI services. So for this model, you can not just use that model, but also you can train a particular model on the custom training or a custom data, and it can still give you the required favorable results in that. And the visual results of this model are quite simple to understand. It's easy to use. I'll show you a small example of a sample input and the sample output of the model. So in the sample input, we will be using these images. This is the type of input. This is the input string that needs to send, that's need to be sent into the model, which it uses two particular images, image one and image two, and it gives us the output in a JSON string with all the coordinates of that particular object in the box of the image. And also it gives us the label, what is the particular object, if it is a carton or a can, and also gives us the score of that particular model. Right. So as I said, the YOLOF model in the Azure AI services comes with pre-built notebooks for the model deployment that you can do that in Azure ML, which we can use real time or a batch inference. If you want to fine tune those models, you can also use this fine tuning notebook. And as a part of this presentation, we will be using the real-time model deployment notebook, which is image object detection online endpoint. I have this in my VS Code. So I just downloaded the VS Code. I just downloaded the notebook here. So to run this notebook and to deploy this model inside Azure ML, it will take more than 10 minutes to deploy that model, to install those dependencies and libraries, which I have already created. In restrictions of the time, I have already created a video for that. So let's take a look at that. So yeah, here I'm running all the Azure, all the cells in the notebook. Firstly, it imports basic libraries, and it uses the authentication of your Microsoft account, which can also be your organization account. So once we run this cell, it opens a window in in the background to authenticate this procedure. And we have to mention this subscription ID. What is a subscription ID that we are going to use? What is the resource group that we have created for the Azure AI or Azure ML service, and the Azure ML workspace name? So once we have authenticated this, once we have done with the authentication, then we will be using this MMD 3x YOLOF model. We are defining the model here and the version number here. And here we want to see on a local data set instead of a camera feed, firstly, to see if it is able to detect the image on that. So here I have the data set of different images of a carton or an image, which is a object detection sample data set, which is provided by Microsoft in the Microsoft documentation. So here I'm using a image 99, which is a bottle, and here we see that okay, it is taking the image into the variable, and we will use this image later to send it to the model again. So it takes around 10 minutes, more than 10 minutes to deploy this particular model on the Azure ML workspace. Here we will be defining some thresholds. Okay, what are the type of thresholds that we want? What are the types of timeouts or requests that we have to send to the model? So yeah, after 10 minutes, the model has been deployed into the Azure ML workspace. And now let's see if it can score the image that we have sent into the model. So here we are sending the model into the, here we are sending the image into the model. And we see the output of this particular model comes with coordinates of the particular object in the image, and it has sent us a label with a bottle and also score. But it also has it also scores different objects in this particular string. So that's the output that we have received. That's the raw response. But we have to transform that response and get the best object or the top object from this output string. So let's confirm if we have the model deployed in the Azure ML workspace. Here I have my Azure ML Studio workspace. I have my workspace already created, but if you want, you can create using this create workspace. So in the workspace, we don't see any models deployed here yet, right? And these are the notifications that we received after we have deployed this particular model. And in the Azure ML Studio, you can define different assets. If you want to train that model on your data, then you can use a data set and train that model on that. And here you have some other assets like jobs, which can perform ML jobs or pipelines, or which can be used to transform this particular ML jobs. So here we see the endpoint has been deployed successfully, and if we go to the ML endpoint here, we can see the model has been deployed onto a dedicated compute resource, and we have some endpoints which we will be using later to use this particular model, and also to ingest that into Azure event stream hubs. So to get the model and to use it, we have to use this particular REST endpoint and then the API keys from this. So I have this code which I have already used. I have designed this code which will basically consume that particular model and uses my camera feed and ingest into the Azure Event Hub. So here we are defining the endpoints of the Azure Event Hub. What is the Event Hub namespace? What is the Event Hub name? And here we will be using the default camera of my laptop by using CV2 module. And we also define the URL, which is the REST endpoint, and also the API key, which we will be using to authenticate the model. So here I wanted to send this first frame and see the sample result of this model, like if it is able to detect and recognize this the object which is sent into the model. And we have a JSON file here. So we have a JSON file here, which is the sample response that has been sent from the model, and we see the label is person and the score, and also it detects different labels, as I said before. Yeah. So let's run this script again in real time to see if it is able to inference and give us the output as required. Yeah, so I'm in front of the camera, and here it says the the first label that comes here is the person with a score of 0.72, which is 72% accuracy, I would say, which is quite good. I'm in front of the camera, but it also detects other objects like umbrella, or which is kind of similar, could be similar, the model things. And once we get this output string, the result will be sent immediately to the Azure Event Hub, which we will also see here. So you can, of course, create the resource of event hubs from here. I have already created the same. I have my event hub namespace. And if we see the successful requests of incoming requests and outgoing requests. So as of now, the outgoing requests that I have already connected to a Fabric workspace, and that is why we see outgoing messages. And these are the incoming strings or incoming responses from the model to which are ingested into the event hubs. We see that yes, we are able to receive the incoming request. So that is successful. We have successfully ingested the data into the Azure Event Hubs. Right. So let's do a quick check what we have done until now. We have detected an object using a camera and an IoT device, which sends to the model endpoint from the model endpoint in the model that is present in the Azure ML workspace. And that particular response will be cloud streamed to the Azure Event Hub. And we will go to the Azure workspace, how we will use this Event Hub, how we will do these real-time transformations inside a stream job, and later see this particular output in a real-time dashboard. So to see the lineage of the Fabric workspace that we have here and how we are using it, we have a stream job, which is event stream, which does some transformations in real time and takes that output, sends to a Fabric item reflex, and also stores it into a KQL database, which is in an event house, streaming event house. And then that particular KQL database is used by KQL query set, which we will use it in the real-time dashboard. So that's the architecture of the Fabric items in the Fabric workspace. So we have a Fabric stream job here. Let's look into the stream job and see what are the transformations it is doing. So I have saved these images from the stream job just to be sure we don't have if it doesn't have any internet or something. But let's take a look into that in real time if it is able to perform this transformations. So I'll go into the edit mode. We have the stream job, which takes the events from the Azure Event Hub. Here you can define the Azure Event Hub with a cloud connection string, which you will be getting from the Event Hub here. So we can go to the Azure Event Hub again, configuration, shared access policies, and we have a policy to manage send and listen. So we will be using these connection strings, and we will be getting the data from the Azure Event Hub. And you can also define different consumer groups. Let's say if you want particular users to not to get the whole data out of these strings, then you can define different consumer groups here. Let's say we go to so in the entities, we can define a consumer group here. Here we can also define just Fabric consumer group who will only be using a Fabric workspace, right? So we can also feed that. So we can also feed that as a consumer group here, but right now I'm just using a default consumer group. So it takes the data into the Azure Event Hub, processes into, it creates a stream, a real-time stream of this particular data that is coming from the Azure Event Hub. And here we are doing some transformations. As of now, we have different columns here, and I don't want the partition ID or the event processed time. So I will just select those columns that I need. And the data that we need is in this JSON strings. So we will be expanding them, expanding the array of the of that particular string. And we will also mention that we don't want all the objects or all the labels, but I want only the labels that are greater than 0.4 or 40%. But you can of course adjust it as per your requirement. And we have the final data set in a JSON format with all the strings which has the accuracy above 40%. Let's see that. So we have all the objects which are 40, 47, 73, 93% accuracy. And that will be streamed into a KQL database and also to a reflex, which we will be later using in the RT dashboard. So let's look at the streaming event house before that. So we have created an edit version. We have edited or created our stream job. Now let's see if it is able to capture the events in the real time. Yes. So it currently uses a UTC time, 7th, 13th July, and it takes the data, sends it into the reflex in this particular format with the columns that are being transformed and expanded with the scores, coordinates, and also if we want when is this particular signal has been detected or pushed into the Azure Event Hub. Here we have the coordinates. Here we have the score. That is what we will be using in the RT dashboard. Right. Let's look at the KQL database as well. In the KQL database, we will need the JSON strings. In the reflex, we will need in the tabular format. So we have the event house here. You can, of course, create these resources in the Azure in the Fabric workspace by creating. From here, you can create a reflex. Here we will be using the real-time intelligence options, event stream, which is a stream job, reflex, event house, KQL query set, and real-time dashboard. Let me give you a short intro of what they actually are and what they do. So the event stream, it captures the data in the real time and transforms in a required format in the real time scenarios. So once we have captured and transformed in the stream job or the event stream, then it loads into a event house, which will be used in a KQL database. And once we have the data, we have to query. So not the SQL query or since it is a KQL database, we will be using a KQL query, and we can view those results of that particular query in a real-time dashboard. And coming to the reflex, reflex can trigger, activate, monitor in a real time if there are any anomalies, if there are any detections that we have set up particular triggers. I will also show how I have assigned some triggers when the scores reach particular numbers. So in the Azure event, in the streaming event house, we have a table Azure AIOD, and we have the columns which are being ingested into the KQL database, right? And yeah, if you want, you can also query the table to show any 100 records from here. I'll just quick check uh, if it is being performed. So yeah, here we have the table, which is the latest time as per the UTC. We have a JSON string with the labels and the score, which is the top label with the score that is above 0.4. And coming to the reflex, here I have last 15 minutes. And just before the presentation, I have used different objects in front of my camera to detect. And right now I'm just sitting in front of the camera. So it detects only the person. But let's say if I put a cup, um, probably I should be away from the camera. Yeah, sometimes it takes the accuracy needs to be correct. It still doesn't detect any image as of now, but it can detect different images. Yeah, so it has detected a cup just right now. And here we see in the last 1 hour, I've been just sitting in front of the camera, so it detects only the person and now the cup. So using this reflex, we have defined different properties here. I wanted to see, okay, in a airport environment, we want to detect particular objects which needs to be flagged. Let's say a person is carrying some objects which are not supposed to be carried, and it can detect in real time, right? So uh, we have the objects with the scores here. Also here we see the scores of this. Here also we see if the objects which are detected on which particular time basis. Right. So here I have designed a trigger. If the score is above 0.8, send me a Teams message right away. So it is detecting the person which with the score above 0.8. If it has, then it sends me image. It sends me an alert in my Teams environment. Let's look at that. So I just got this alert from that my trigger has been met with the following condition, and the image or the message that has been feeded into that a person detected. What is the object, the person, and it will also give us the scores. And we can here also add the coordinates. Where is this particular object? So in a airport environment or a large space environment, it is quite easy to understand. It's not just object detection, but also where is this object, or where is this object has been that has recognized or flagged. And the other options that you can also use our Teams email. You can get an email or Fabric item. And also you can have your Power Automate flows. For example, if you have a Power Automate that needs Power Automate flow that has been designed to trigger by getting the output from the Fabric item reflex, and it can send you a notification. For example, if it is an IoT device in a factory environment, let's say. And here I'm using this query to give me the labels, score, the time that has been the time that was the object was recognized or detected, and the box coordinates. And we will use this query. We will run this query now to see. Okay, there was a chair object before. Let's refresh this. And we see the coordinates here. So in the real-time dashboard, I have these two visuals to see the time. Right now, it runs every 10 seconds to detect different images, to detect different objects, and gives me in a list of different objects. So for the last 1 hour, as I'm in front of the camera, it was just person. But if we see in real time, it can show if there are any flagged objects. It can show right up here if there is a cup or anything that we want to see. Here we can also see the scores of different objects. Right now it's just person, so we see the person has been recognized with different scores. Right. Yeah, so let's take a look at the same thing in a standard format. Here we have the KQL database. We get the uh, output from the query. We have the Fabric reflex, where we will be detecting this object on a time format, and a real-time dashboard with the labels, scores, and also the coordinates here. Right. So let's take a quick recap of what we have covered in this presentation. We have detected an object using a camera device, which is later sent into the image is sent into the IoT device, into the model endpoint, the model which is YOLOF in the Azure ML workspace. And once we have received the output from the model endpoint, this should be a two-sided arrow. So once we have received the model endpoint, the response from the model endpoint, we will stream that data into the Azure Event Hub namespace, and then we have a Azure Event Hub. Later, that will be consumed by a stream job where the transformations happen in a real time, particular columns or expanding the arrays or particular objects that we need, and we will also send them to the reflex item, which we will be creating which we have created some alerts in real time alerts, and also to see the reflex item, what are the objects on a timely basis, and store the data in an event house in a KQL database, and later use KQL queries to view the real-time dashboard results. Yeah. So yeah, that's all. Thank you so much for sticking in this room and hearing about the presentation. And I'm very much looking forward to your questions and have some discussions. So you can find my LinkedIn, email, and my website here, where I write some blogs on Microsoft Azure cloud environment.